This is Teach Chem Forever, and I'm here to give you a quick tutorial on the atom. So we're starting chapter 2, and this is the first time that we're really going to talk about chemistry. I'm so excited, and it's about time, right? But anyway, I'm going to put my computer down so I can write, but you know I'm always here. All right, so when we talk about the atom, we have to talk about the three fundamental particles, and that would be the proton, the neutron, and the electron. I'm going to change markers. The proton has a positive charge, the electron has a negative charge, and the neutron, of course, is neutral. Most of you also have looked at a periodic table before. Maybe you don't understand it, but you have seen it, and you'll notice that there's a symbol, and then there's a number on the top, and then there's a number on the bottom. Well, just that symbol right there, that little box, can tell you a lot of information on the atom itself. For example, the number on the top tells you how many protons that element has. And the proton is super important because that identifies the element. It's sort of your social security number for a human being, right? So if you have a social security number and only you have that social security number. If you change that number by one digit, well, it's not you anymore. It's the same reasoning for elements. If you change the number of protons, you change who that element is. So the number on the top tells you the protons, and that's really important because it identifies who it is. At the same time, since all of these elements are neutral, it tells you how many electrons it has. It also tells you the number of electrons. If it has 7 protons, for that element to be neutral, if it has 7 plus charges, then it has to have 7 negative charges for it to be neutral. So it tells you at the same time the number of electrons. The number on the bottom is called the mass number. And that tells you how many neutrons, because that's the only thing that we haven't talked about, right? It tells you how many neutrons it has. Okay, so let's break that down a bit. The mass of the atom, right? So this is mass number, so it's obviously talking about a mass. But most of the mass of the atom comes from two guys. It comes from the proton and the neutron. And these two guys live in the nucleus. Okay? So you've got an atom, and let's call this the nucleus, right? Here is where all the mass, most of the mass, not all, most of the mass is in the nucleus. Oops. So in there, you're going to have the neutrons and the protons. Then what lives on the outside? On the outside are the electrons, and they live in these little things called shells. I'm sure you've seen them before, the picture of the atom. But they live orbiting the nucleus outside. So you've got all the plus charge, all the plus charges, and the neutrons that have no charge in the center, and that center is what weighs the most. So when you look at this number, and then the electrons obviously, but electrons don't weigh almost anything compared to what the protons and the neutrons weigh. So going back to our symbol, you have this mass number. The mass number really tells you the mass of everything in there. But what is the atom mostly composed of? It's composed of mostly protons and neutrons. So if the thing weighs 7, right? I'm sorry, if the thing weighs 14.01 and you have 7 protons, because we have it up here, then how many neutrons would that element have? Well, 14 minus 7 is, let me write that down, is 7. So that means that it's got 7 neutrons. So you can tell here that the symbol tells you a lot of information. It tells you, number one, how many protons, how many electrons, and how many neutrons. I want to go back a little bit to concentrate on what I said about the periodic table. Every element that you see in the periodic table is the most common neutral atom of that element. What do I mean by that? Since the mass here, right, tells you the number of protons and neutrons, then there are these things called isotopes. Okay? And isotopes are whenever you have a different number of neutrons in that element. So for example, nitrogen. Nitrogen, you'll have nitrogen 14 and nitrogen 15. And then there's also a nitrogen 13, but I believe that's a synthetic radio isotope. So we're only going to concentrate on things that are not radioisotopes. We're just going to concentrate on stable isotopes. So anyway, let's just go back to isotopes. Isotopes means that you have a different number of neutrons. Remember, what do you see in the periodic table? On the periodic table, you see nitrogen and it weighs 14. So that tells you that nitrogen 14 is the most stable isotope of a nitrogen atom. If you, for example, were talking about nitrogen and instead you saw something like this, it said nitrogen 15, then the mass, that's telling you that the mass number is 15. So what does that tell you? Going back to our periodic table symbol, you know that the number of protons for nitrogen does not change. It is always 7. So if it has 7 protons and you know it weighs 15, what is 15 minus 7? 15 minus 7 will give you 8, which tells you that this nitrogen, the nitrogen 15, has 8 neutrons versus the 7 neutrons that we had in the original most stable isotope. Isotope, again, means different number of neutrons. The most stable isotope is the guy that you see on the periodic table. So let's recap. Let's look at another element. If I instead gave you this element, and let's say that you knew that there's 2 stable isotopes of carbon. It's carbon 12 and carbon 13. Okay, let's just put that on a side box. But I want you to tell me how many protons does carbon have. You should be able to quickly say that carbon has 6 protons. And since you know that it has 6 protons, how many electrons does it have? You should quickly be able to say that it has 6 electrons. And by looking at this mass number, you should be able to tell me how many neutrons it has. Since it weighs 12, and I know that it has 6 protons, so 12 minus 6 would be 6 neutrons. So there is an easy way to be able to figure out how many protons, how many neutrons, and how many electrons. Also, are you able to tell me which carbon isotope am I referring to when I say carbon? When I show you this symbol, I'm obviously referring to carbon 12 right here because we just counted that it has 6 neutrons. If I had carbon 13, then the mass of a carbon 13 atom would be different. It would actually be 13 point something, which I don't know what it is. But that would mean 13 minus 6, which would tell you that the carbon 13 atom has, instead of 6 neutrons, it has 7 neutrons. Well, I hope that wasn't too confusing, but we're going to go over that in class again, and I'm sure you'll get it all perfect. All right, guys, make sure to go over all of these sections and watch these videos, and of course, think about these questions, all right, so we can discuss them in class. All right, see you later.